Good day everyone, welcome to this additional lecture on plan shapes and rates per square meter. So today we're going to look at the AECOM report and specifically pages 35 to 38. So make sure that you do have this document available. So firstly we're going to consider two basic shapes. So we're first going to look at a square shape, and then we're going to look at how that will influence the cost of the building. So if we look at the first shape, firstly the square shape, we can estimate that 40 times 40 gives us a square meter floor square area of 1,600 square meters. We can add up the wall lengths of 160 meters, and if we work on 3 meter high walls, we can see that the vertical height of the walls and the vertical area of the walls is estimated at 480 square meters. To calculate a rate per square meter or a cost ratio for that, we simply take our total wall area divided by our floor area to get the wall floor area ratio. So looking at a second shape, a square shape with the same area as the square or a rectangular shape that has the same area as our square shape, we can do the same exercise. So we can see that the floor area is amounts to the same amount, but our length of our walls now increases to 232 meters. Where if we apply the same height, we can see but the floor or the vertical area of the floors or the walls is now 696 square meters. So if we need calculate our floor or our wall to floor ratio, we can see that it amounts to 43.5% of the total for this building. So this is very good and well, but the implications of that is one can see that the rate per square meter on plan of a facade costing 800 Rand per square meter on elevation. We apply that to each of the cases to see what the implication is. So we take case A, which is the rectangular, the square, and we times that with our 50%, and we can see that the floor cost ratio or the wall floor ratio amounts then to 240 Rand per square meter, whereas we apply to B, we can see it amounts to 348 Rand per square meter. So you can see that there's a difference between the cost of the brickwork for a square building compared to a rectangular building. Thus, it is one can see that the rectangular building will have a higher cost because of that. So the reader can also acknowledge that that the circular shape will have the lowest cost, because the wall length for a circular shape for the same area will be lower, or the lowest of this. But one has to take into account that usually round walls has a higher cost to construct because it's a specialized field, and the bricklayer that has to construct that wall has it just has a higher cost because of the specialization and the degree of difficulty to construct that round wall perfectly. So the floor to ceiling height. So then the book just continues with the floor to ceiling height. So it's important just to note that it has an influence on the cost of the building as well. And then the plumbing, mechanical and electrical installations also has a big influence on that. So you can just read through that. This is for information purposes. And similarly in commercial and industrial buildings, the rate per square meter will also depend greatly on air conditionings, etc. So this is quite handy, especially if you use the AECOM book. It's always a good place to start whenever you start with nothing really in hand on cost, or whether you may have historical costs of house constructions that you were involved in, but now suddenly you are confronted with a client who wants to construct a office building, and if you have to do an estimate on that, then the AECOM book is a good reference to start off with. So the book also delves into the rate per square meter for buildings with large balconies, etc. And then internal divisions also has an influence on the cost. So the higher the cost, or the internal divisions, the higher the cost would be as well. Okay, so the second item that I just want to have a look at as well, which is in the book, is the cost per square meter and the influence of integrating your parking in the building by means of a parking basement or via a external parking. So the example that we're just considering is to get to a point of your rate per square meter. Is it higher for integrating it in your building itself, or will your rate per square meter increase or decrease if the parking is on the outside of the building? So let's have a look at that. So the cost for our first building, where we integrated in our basement, we can estimate that our offices amounts to 2,400 squares for the building, and we applied a 15,000 Rand per square meter rate to it, and we can estimate that the offices amounts to 36 million Rand. And then we do the same for our parking bays. We apply 6,000 Rand per square meter for that, and we can then estimate the parking area cost. If we add that together, we get an amount of 39,600,000, and if we divide that with the total floor area, which is 3,000 square meters, we get to a rate of 13,200 Rand per square meter for the building. Whereas if we take the parking outside of the building, we estimate our building or our offices to be the same, but now our parking has a lower cost per square meter for the parking area because it's outside. We can see that the total cost of the building went down. However, the cost per square meter went up because we're now dividing it with 2,400 or 2,400 square meters and not the 3,000 square meters as we did in the first example. Thanks everyone, and just a very brief description of how the shape of the building influences the cost of the building, as well as other considerations for whenever you're doing your cost estimation on buildings, and how it influences the cost. So yes, please go through the book that I sent through, and yeah, good luck to everyone.